Remove front input bearing shim. Note that sometimes they will stick to the transmission flange. Remove drain plug with a 5/16 square drive adapter and drain oil. Using a 9/16 socket, remove both shift detent plugs, springs, and steel balls. Use a 11/16 to remove top vent and 15mm to remove fill plug. With the detents removed, it is now easier to align the shift rails into the orientation shown here to align shift interlock for front output housing removal. Then, remove shift linkage. Use a 29mm and yoke holding tool to remove front and rear yokes. Remove rear input cover and rear bearing cap with a 9/16. Remove speedometer sleeve with a 15/16. Remove speedometer driven gear. Remove idler shaft retaining bolt with a 1/2 inch. Drive off rear input cover and remove input shaft. Strike side of output bearing retainer to twist it. This will allow pry bar access. Keep factory shims. They will be needed later. Remove oil baffle and speedometer drive gear. Use a 9/16 to remove front output housing. Verify shift rail alignment as demonstrated earlier. You should be able to wiggle both shift rails in either direction when properly aligned with the shift interlock. If your shift rails have an excessive buildup of rust, it will need to be removed. Remove shift interlock. Remove front output shift rail and collar. Remove front output bearing snap ring. Remove front output shaft. The bearing may or may not come out with it. Use a 1/2 inch to remove bottom cover. Strike output shaft in both directions to move bearing cups outward. This will make room to remove front bearing snap ring and thrust washer. Use a pickle fork or similar tool to slide front bearing forward. Remove snap ring and then output shaft. Rotate output shaft to access the snap ring. Remove idler shaft. Remove idler gear and associated parts. Cut wire from range fork and remove lock bolt with a 7/16 12 point and wobble extension. Sometimes there's a little burr from the lock screw that may make the fork separation difficult. Gently pry, twist, and tap until you can separate the two components. Clean all mating surfaces with a gasket scraper. Use QT9301 to remove bearing cups from main housing. Remove all old seals. Use a blind hole puller or similar tool to remove rear input shaft bearing cup. Use blind hole puller to remove front output shaft bushing. To stabilize the shaft for this video, we are using components from TS1256 Roxor ball joint tool set as a holding fixture.
Danger.
Let's try that again.
Danger.
Use a split bearing puller to remove bearings from input shaft, rear output shaft, and front output shaft if still present. Clean and inspect all parts for wear. Replace as needed. Reassemble with TK2034 Roxor Transfer Case Master Overhaul Kit. Use QT1813 cup installer with QT1116 driver handle to install rear input shaft bearing cup. Use QT1044 to install rear bearing on output shaft. Use QT1004 to install front input shaft bearing first. Then use QT1044 to install rear input bearing. Use QT2086 to install front output shaft support bushing. In this video, we used a 3D printed prototype that failed. However, the production steel tool will set your new bushing at the correct depth. Use QT2082 to press in both output seals. Long side is for rear output and short side is for front output. Use QT2083 to press in shift rail and speedometer nut seals. Use a suitable tool to install front input and front output bearing cups. For now they are set flush, but will be adjusted deeper in later steps. If desired, you may drive both cups with QT9301 a little beyond flush at this time while the case is horizontal. This will provide working space to set your front housing, pilot, and input bearing shim. Insert range shift rail into the main case and slide on shift fork. For final installed component orientation, single interlock grooves in rails will face each other and flat side of shift fork goes towards rear of case. Align countersunk hole in rail and thread in lock bolt. Torque between snug and 10 foot-pounds and secure with new tie wire. Apply a generous coating of petroleum jelly inside the idler gear. This is preferred due to quick washout during initial operation. However, if you live in warmer climates where petroleum jelly will quickly melt, a wheel bearing grease is an acceptable alternative. Stick in first row of roller bearings, then add a spacer washer. Flip idler gear, add another spacer to separate bearings, and add the second row. Place third spacer on top of the rollers. Use a little petroleum jelly or grease to stick idler gear thrust washers inside the case. You may use the idler shaft and a similar sized socket to help keep them centered as you slide in idler gear. Remember, big gear on idler should be oriented to the front. Be sure retainer cutout is properly aligned before tapping the shaft all the way in. Check for free rotational movement and install retainer tab and bolt. Torque to 10 to 15 foot-pounds. Slide low gear over shift fork and insert the output shaft. Then add high gear, thrust washer, snap ring, and front tapered bearing. Here is a better view of components in order. Note the thrust washer has two inside tabs that will align with corresponding grooves on the output shaft. The snap ring groove is here, and the front output bearing will slide on here. Use QT1044 to seat front bearing against the snap ring. Align the assembled cluster and use QT1004 to drive in rear bearing cup slightly above flush. Bearing cup stick out will seat inside rear bearing retainer. At this point, lateral shaft movement is normal. Check that everything shifts and rotates freely. Insert input shaft and clean case and rear input shaft flanges. Apply anaerobic sealer and align groove in rear flange with case mounting bolt hole. Thread in all bolts to use as a guide and seat the flange with a soft hammer. Bolt torque is 30 to 35 foot-pounds. Install front output shaft and bearing. It is a very precise slip fit, however QT1004 can be used if the bearing gets jammed. Install front output bearing snap ring. Keep one end of the snap ring near the edge of the access cutout for easy removal at next overhaul. Full disclosure, sometimes this snap ring can be quite difficult. That's not going anywhere. Apply petroleum jelly to shift interlock to hold it between shift rail holes in front housing. Place front output collar on shift fork and slide assembly into front housing. Apply a few spots of petroleum jelly to hold new gasket in place. At this time, use QT9301 to slightly drive in front bearing cup below flush if you have not already done so. Slide front output assembly onto main case. Adjust shift interlock as needed so it allows range shift rail to slide through. Seat front housing onto main case. The front housing pilot is seating the front output bearing cup to its new home. This hole is the original location for your speedometer harness tie-off point. Front housing bolt torque is 30 to 35 foot-pounds. Verify correct shift operation. Use QT1004 to seat rear output bearing cup onto bearing. At this point, there will be noticeable resistance in shaft rotation. Clean mating surfaces of case and rear bearing retainer. Install bearing retainer and snug fit the bolts. Shaft rotation resistance should see a noticeable increase. Measure the gap between bearing retainer and case to determine shim pack thickness. Measure against your old shims and add or subtract shims as required. Note that original shims may be reused if in good condition. Recheck end play as you add or remove shims. Each time, the output shaft bearing cup can be seated against rear retainer by gently prying back against the high gear. Although not specified in the factory service manual, we set shaft end play to where it can just barely be felt. 1 to 5 thousandths is within tolerance. After verifying smooth shaft movement and shifting, it is time to permanently install rear bearing retainer. Although these shims will usually seal themselves, it is a good idea to add a little anaerobic sealer to each layer. Add speedometer drive gear and oil baffle and torque retainer bolts to 30 to 35 foot-pounds. Place new gasket, bottom cover, and torque bolts to 15 to 20 foot-pounds. Add reusable sealing washer and drain plug. Tighten until snug. When installing yokes, apply petroleum jelly to sealing surface and a little anaerobic sealer to flange nut mating face. Add driveshaft flange bolts to rear yoke before installing. Nut torque is 120 to 125 foot-pounds. Insert speedometer driven gear. Add automotive-grade Teflon sealer to nut threads and tighten until snug. Install detent balls and springs. Add automotive-grade Teflon sealer to plug threads and tighten until snug. Add thread sealer to vent threads and tighten until snug. Install shift mechanism and do a final operation test. The last step is shimming your input shaft. Seat bearing cup with QT9301 while rotating shaft and feel for zero end play. Measure depth from flange face to cup face and compare to original shim. Thickness should be 1 to 5 thousandths less than measured depth for end play. Place shim on bearing cup using a little petroleum jelly or anaerobic sealer to keep it in place. Verify final depth with shim in place. Seal transfer case to transmission with anaerobic sealer. Transfer case mounting bolt torque is 50 to 55 foot-pounds, and side support isolator nut torque is 30 to 35 foot-pounds. Fill transfer case with oil and install fill plug with thread sealer applied to threads. Tighten until snug.